right. So there are like 10 registered, hopefully some 5 will arrive. Okay. Hey, welcome. You made it. Yeah.
I made it. But actually the thing is, I'm kind of sick, so I was thinking to check the timetable and this, like, I don't know what is.
Yeah. So just stay for 2 hours.
Like,
I'm gonna cover the what we are going to do, what's the plan, all that. So no heavy stuff. So you registered. Please put your name and email address so I can map you to the registrants. So. Okay, but that's good. So some people are showing up. Yeah.
I wasn't sure. In some moment I was thinking, was it in Vare?
No.
But or here. But
There are 2 versions. So the Vara version is going to happen in autumn, and then the Fab Lab version is going to happen in spring, because it's so much nicer during the springtime to have this walk over to here, and the place is also there's more nature around. It's much nicer.
like, yeah. So that's kind of the same course, just run in the different locations, or
there are 2. They should be 2
like,
different. They should be 2 different courses, because the machinery over here is different from the machinery in Vara. So this is a Fab Lab, which is trying to fit the Fab Lab concept, and then Vara, it's more like a tech shop where we have a bit more heavy duty tools.
Okay. I never visited.
They have like most of the tools are also overlapping with this place, but the concept is a bit different. Just put down your name and email address. So that goes for you too as well. Please put down your name, email address, so I can map it to all the records. So yeah, I'm gonna wait for some 5 up to maybe 10 minutes, so because people are always late, and so I am hoping to see some. I will wait for 5 minutes and then I will start, and then whoever comes later joins later.
How many there could be?
Oh, so altogether, so we had 11 registrations. So one girl dropped today, so we have 10 registrations.
Yeah.
But I'm being rather pessimistic, so I think like there are going to be 5 people. Yeah, but then we are already 4, so I'm still waiting. So there should be two more. So usually there are 2 people who are late, and maybe 1 who is terribly late. But then I'm also recording, so that if you miss one of the days this week, so you should be here. But if you miss, you have something urgent to do, then it's gonna be all on YouTube, and I will look into ways how to upload it on my courses as well. So it's also as with Fab Academy Thursdays, I'm kind of trying to iterate on this practice of recording and streaming and all these things. Getting better all the time.
What was the webpage where you like book these machines like that?
Alto takeout.
Also.
Takeout. Yeah, takeout.alto.fi. But yeah, well, don't hesitate. Come closer, because it's not going to be only a lecture, but I'd be very happy you to also join the discussion. Okay, so let's start basically. So this is Digital Fabrication Studio, so the Alto Fab Lab edition. So there's another course with the same name that is happening at Vare. But Vara is a bit different, so it's more like a tech shop, and it has more heavy-duty tools, so the possibilities are almost the same, so maybe a bit more, but you actually, during the course, you cannot really cover everything. So the Fab Lab is more like a self-contained space where you can do rapid prototyping, more like a soft Vara. So with the drilling, would it be actually possible for you to move into the other room and do it there? So there's one free table, I see. Thanks. Yeah. So welcome. I'm glad that you made it. So there are 11 registrations, but it's usually the case. If there are 20 people registered and 10 show up, so this time it was 10 people registered, so 4 showed up. Very well. So my name is Chris. I have been studying at the Helsinki Media Lab, so now it's Alto Media Lab. I graduated with a thesis about how to make projection mapping software with the Raspberry Pi. So I made an open source software that is available online that you can use for projection mapping in projects. And you don't have to use your own computer, but you can use Raspberry Pi in order to do that. More you can find out on my website. Now I'm working here at the Fab Lab. I'm managing the lab for some time. I'm not sure for how long. So basically, even after the course, if you have some questions, you can come over and I can help you with things. Yeah, I've been before Media Lab. I was studying painting at the Latvian Art Academy. Went for exchange in Milan, in Italy, in the Brera Art Academy, and this is where I started to do some things with media as well. Because during the first semester, I found an interesting course on painting, but then on the second semester it was not so interesting anymore, so I joined the media department and started tinker around with Maximus P processing and open frameworks. But that was, yeah, some time ago. It's not relevant anymore. Then I went, during my studies here, I went to Berlin to have an internship at the Fab Lab Berlin, and I was building a resource management system for the lab, so which would have user accounts and all the machines registered, and it would have remote switches, and depending on which machine you are using, you can switch the machines on and off, and this sort of thing. Then after that, after graduating the media lab, I spent some time in Berlin, and then went last year. I went to graduate the Fab Academy in Barcelona, which is a half-year long course. I'm going to tell about it more a bit later. And then in parallel, I was always doing freelance and working on projects like this, for example. There's too much light. So yeah, this was a kind of an installation that I made 2 years ago based on the migration data of United Nations. Then I've been playing around also with lasers a little bit and then motion tracking. So Yeah, that one was also like an experiment. It was built also using Raspberry Pi and a Raspberry Pi camera, and it was tracking the shape. So you would need to take care of how the scene is being lighted, and then you would use computer vision, so OpenCV, in order to track the shape, and then you would be able to interpret it into different visual shapes and laser drawings and whatever. So and then here I'm helping people with all kinds of projects. These are also that I showed. These are just a few, maybe not the most impressive ones. So if you're interested in more projects, you can look up my website. And yeah, and here I'm helping people with different kinds of projects, like this one, for example. This we did last week in 1 hour using Fusion 360 and the CNC mill that is over there in the other room. And then, yeah, in the meantime, so when I'm not here, so this is actually a holder, kind of a frame for the HTC Vive tracking puck. So in order for the people to be able to use it in a different kind of interactive setting for doing interactive stage design. And then, yeah, if I'm not here, then I'm cuddling my cat. And then, yeah, so this is what I told. So come closer. I just wanted to somehow also give you the opportunity to talk. I would like to know, you know, who you are, what's your background, what was your motivation to join the course, and things like those.
My name is Yixin Zhang, and I'm from China, and I'm an architecture student. Why I choose this course because I'm interested in digital architecture, so I want to learn some skills or technology about this.
All right. Yeah. Oh, thank you.
I'm Yash. I'm Zhang's homemaker, and we are in the same studio about the digital design. And I am really interested in.
Sorry. Hey, guys, like there's a course going on, so if you have discussions, then maybe do it in another room. Yeah. Sorry.
I'm really interested in all the materials that work here, so I just want to use them.
Hmm. All right. And you're also from architecture department, or you're from? Also, of course. All the universities from architecture department. And you?
I'm Yisang. I also come from Department of Architecture,
All right.
and I just attended this course because I want to learn some digital things to maybe this will be helpful for my design, and at the same time I want to get enough credit for the next year's scholarship.
Oh, okay. Yeah, credits. Important. Yeah. So, and you?
My name is Nora. I'm from the University of Helsinki class studies. Actually, trying to learn this course. I went to the basic course, but I still didn't see anything.
Okay. Yeah.
I hope I can put more time.
Hopefully. Yeah. So this is kind of I was designing it and keeping in mind that you kind of already have some basic knowledge, but then the basic idea is to show some progress that you actually learned something during the course. And then yeah, your background is in craft. All right. Yeah. So then, yeah, basically, let's talk about Fab Labs. What is a Fab Lab? So it's not just a place with tools, but it's also a place where you can share knowledge and experience about the tools and designs and other things. And it originated at the MIT, Massachusetts Institute of Technology, at the Center of Bits and Atoms. And it started with a course that is called How to Make Almost Anything. And the special thing about this course, it was around more than 10 years ago or 12 years ago. don't exactly remember the years, but yeah, the special thing about the course was that it would be an attempt to open up the engineering tools, which would be previously available only to engineering and maybe architecture students, to other people like artists, designers, musicians, doctors, like anybody in the campus. And it proved itself to be very successful. So there were many different people joining and using the machines in their own ways and producing really interesting things. And from there, the concept of Fab Labs originated. So which would which is about being able to make a digital design in one of the labs, iterating on it and producing an outcome, documenting it, and then sending that digital file and documentation to any other lab around the world, which would be a Fab Lab. Behind this is a professor whose name is Neil Gershenfield, and he's the director of the Center of Bits and Atoms at MIT. And yeah, you can see also the link of his website. But I'm going to share the slides anyway, so you don't have to worry about that. And yeah, he has a website, and he's generally very, very smart. This is his picture. And yeah, when you so we'll have also the opportunity to look at the Fab Academy lectures every Wednesday, and maybe some recitations on Mondays. And you'll see that the topics that are covered during the Fab Academy, they are so there's a crazy amount of knowledge, and it's kind of, if you start to look at that and you start to think about that, then it's kind of crazy to. I mean, it's a lot of knowledge, and it's crazy to think about the fact that one person could actually understand it all. But then, so during the Fab Academy, you would, and if you join Fab Academy and you explore the network, you will find out that there are actually a lot of these kind of people who are taking up the challenge to actually try to learn everything, and who are trying to learn how to make almost anything. And with the technology today, it's not impossible. Then there are other concepts, so it's not just the Fab Labs. So the Fab Lab is so far the most organized, in my opinion, so more like standardized and put it into a box. But there's even before the Fab Labs, there were hacker spaces. So one of my favorites is Hackspace London, for example. Or if you go to Berlin, then you should go to the C-Base, which is the oldest hacker space in Europe, for example. Then there are maker spaces, which are more like hobby / startup spaces, where you can go and repair stuff, and you would build like your first prototypes, mostly because you would try to make business out of it, and yeah, repairing things. Then there are tech shops. So it was a US concept. Actually, it failed miserably because of the fact that so it just went bankrupt because there were a lot of high-level tools, very complicated tools, and these machines, they usually cost more than 100,000 euros each, and then to kind of earn that money, that investment back, it was not enough with the existing user base and with the business model that they were trying to employ. But so in a university setting, something like Vara could be considered a tech shop. So it has all these high-power tools. It has like this metal lathe. It has a CNC lathe. It has a metal CNC machine. It has a jet cutter. So you can build satellites there. Maybe almost, but yeah. So this is an image of a tech shop. So you see that that machine the guy is working with, it looks quite serious. So yeah, you need a lot of space around in order to make it safe, and yeah, this is, you know, you need some experience. You need to work with it a lot in order to understand how it completely works. Then there's also this standard or manifesto about Fab Labs. So what is a Fab Lab? So you can check that online. It's called the Fab Lab Charter. So these are general guidelines about what should be at the Fab Lab, how it should work. For example, that the Fab Lab should have at least one open day every week, which we have on Thursdays. Among other things, so a perfect Fab Lab is also a place where you are able to run the Fab Academy. But the standard is also not carved in stone. So once you join the community, you also find out that in the regular meetings there are discussions that, initially there was this funny thing that Neil thought that there should not be a kitchen into the Fab Lab, but then a lot of Fab Labs reported that having a kitchen is important because people gather around coffee and they actually want to talk with each other, and it's nice to have this kitchen aspect at a Fab Lab. So now there are people pushing for the fact that should be included into the Fab Lab charter, that every Fab Lab should have a kitchen. Yeah, and then there's Fab Academy, which is so a course where you learn to use and build a lab. So if you read their website, yeah, it's also an invitation to learn all the skills in order to kind of make the network of Fab Labs spread. So you would get familiar with all the tools, and then you would go back to your city and you would try to make a lab yourself. And it's a global network, and that's basically the best takeaway from it, that it has all these other Fab Labs interconnected all around the world. And during the Fab Academy, you can really feel that. So if your lab doesn't run the Fab Academy, then it feels a little bit disconnected. But the Fab Academy is just this thing, apart from the yearly conference, yeah, that keeps it somehow all together. Then yeah, it's a good way to validate the lab. So while working here, so this year we don't have a lot of Fab Academy students, but still I'm trying to follow the course and maintain the lab in a way that it's actually compatible with the Fab Academy. And then yeah, we can take a look at the website. Well, what happened? Yeah. So this is the Fab Academy website. Yeah, like but basically you can see, like, under the content tree, you can see all the years, documentation of all the years when it has been happening. Yeah, from 2018, for example. So yeah, here you can see the schedule, for example, and like all the topics that are covered. So it starts with basically with presentations about what you want to make during the Fab Academy, some things about project management, but it's more about how you do your documentation. So usually people are encouraged to use some text-based documentation. Basically, everybody needs to make a website, and then they need to learn Git and GitLab in order to maintain the website, like to update it continuously. Then there are weeks about a lot of weeks about learning computer-aided design software and using it for cutting, for electronics production, then 3D scanning and printing, electronics design. Then there's a time when you start to learn more about electronics, and you learn how to design it and how to program it. And mechanical design, so basically where you have to try to build your own machine, like a simple CNC machine, so that you understand how the machines in the lab work from bottom up. And then if something breaks, maybe you are not able to repair everything yourself, but at least you can, like in the case when you build your own machine, then you can definitely repair it yourself. Yeah, and we can take a look at some of the final projects here, for example. So let's look at this one, United Arab Emirates. So just random. There should be video somewhere. Okay. Here we have the videos. So these are the dates. Okay, so this is one. Let's take a look at 3. Seoul. Let's try. All right. So let's see. What's up? Okay, one more. Let's go to another day. It's 22nd, no, 20th of June. Beijing. Maybe. This is the one. So this is the project, like a lot of friends of mine were talking about. I haven't seen this, but it's quite crazy, no? You basically design a bird from scratch. So yeah, as you see, the Fab Academy website is full of resources, so it's full of stuff for inspirations, and of course, like each of these projects that you see here on the website, they took like half a year to make, so the expectations for this course is not as high, unless you have an ongoing project already and you want to use the time at the course in order to work on that. So let's go back to the slides. So yeah, let's stop here. Let's talk about this course. So it's going to be about your project. So during the basics, I expect that Kane introduced you to all the basics, and you know what's generally going on at the Fab Lab. But I'm going to give a tour after this introduction anyway. So what I would like you to focus on, one, or like most of the people do, and they stick to the laser cutter, and then the projects, they are, they're just limited in the scope of what laser cutter can do. I would like you to explore the CNC machines, so 2D milling, 3D milling, electronics production, maybe a little bit of programming, and yeah, maybe if you can do molding and casting, that would be grand. And I want you to document. So for this week, I can kind of record your appearance here, but then for the following weeks, I want you to work on your projects and ask me questions if you are in trouble. But basically, the way how I will validate your time spent on the course is going to be through documentation. And then the idea is actually to gain as much as possible from the course. I just want to see that you actually, what was your state when you started the course, and what did you actually learn during the course, so you can see that you actually grow. And there are 4 weeks together. So this week we enter the flow, and then we work, hard work. Especially the last week, as you can see. And then on Mondays, I would like you to have like updates in a form of a presentation, what you have done the previous week. So next Monday, I would like you to have a few slides about the idea, what you want to make during the course. And then the 2 following weeks, the last 2 weeks, I just want to have, I want to see how you are progressing on your project. And then on Wednesdays we will watch Fab Academy together. So just we will have this Wednesday we will have 1 or 2 hours of introduction like today. So it's going to be about software, and then I'll just activate the Fab Academy feed online stream, and you'll be able to see how it actually goes, what's going on there. And apart from that, we just use the lab as much as possible. And so yeah, this week we are going to recap the basics, so which is vinyling, laser cutting, 3D modeling and printing, and CNC milling, and electronics. It might be the hardest part, but still I think it's kind of nice to start touching it as early as possible, because in the future I think the electronics knowledge is going to be more and more valuable. And it would be nice that there are more people who understand more about electronics and can build custom things. And then, yeah, every day from this week, I'm going to cover software and hardware. So in terms of software, so we are going to use Adobe Illustrator for vinyl cutting and laser cutting mainly. And then we are going to use Fusion 360 for 2 days. On Wednesday, I'm gonna show you the basics and how to export a 3D model from it for 3D printing. And then on Thursday, I'm gonna go a bit more in depth, and it will show you how to create toolpaths for the CNC machine while using Fusion 360. And on Friday, it's gonna be the most exciting. So we are going to use CAD software that is specifically designed for making printed circuit boards. And it's KiCad, and don't be afraid, it's all doable, and it's just software. You don't have to make that software yourself. So in the goal is to master one or several aspects of the Fab Lab, so you can come here and feel at home and prove that you learned something by documenting and show that your chosen project has moved forward. And I want from you documentation, and you should use the simplest form possible, which is plain text. I don't like, like any kind of Word files or PDFs. Like plain text is the best because you can copy and paste and you can modify it in so many ways. And then I would like you to keep the images separately and reference them in text if necessary. And then at the end of the course, I would like you to try to make a short video. So yeah, approximately 1 minute, full HD, MP4. And these days, like everybody, all of us, we have this. Just keep documenting, keep recording what you are doing, and it's gonna be nice for you afterwards as well. Then you will be able to show your friends that, hey, I did this course, and I made this, and what you done that time? No, nothing. You don't have any documentation. Haha. Yeah, so think about what you want to master, and prepare a presentation for next Monday. So I'm gonna keep repeating this every day this week, and try to be realistic. 1 month is really, it's not a lot. So even half a year, it's not a lot. But 1 month, you can really, try to choose the thing that you want to do carefully, and it can be an ongoing project. So for example, if you're doing something for your master's thesis, then it could be part of that. And then for homework, so this is not yet the end of the lecture, of course, but for homework, I would like you to read something about Fab Labs or digital fabrication. So thus I have some books here on the table. So this one is really good about electronics, but don't read all of it. I'm sure you can read all of it. But just choose one chapter. So let's say 10 pages. Read it, think about it. So this, for example, is the Fab Lab book. This is the latest from the Gershenfield brothers about the Fab Labs and this digital revolution, digital fabrication revolution. Then this one is a good one for about 3D printing. It explains the technologies, the different technologies behind it. This particularly, I haven't read it, but it's more about the maker movement. Then there are some books about electronics again. So this is like from the Make magazine. Then this one is about how to build CNC machines. Yeah, so there are a lot of materials. You can even choose some article online. You can check Wikipedia or some interesting articles online, blog articles, read those, and then just think about it. And with the idea that it would help you to understand what you want to do during the course a bit better. So this page was supposed to be for reading hints, but I already showed you the books of the list. The list is not static, so you're free also to choose any of the books that you see there in the bookshelf. So no, yeah, so still, I want to show you some things about documentation. So I don't know whether you have heard of Markdown, so which is a text-based markup language, kind of simplified HTML that is HTML friendly in a way that there are many frameworks, many libraries online that can transcode it into HTML very easily. And yeah, I wanted to show you some of that and some of image processing techniques and a little bit of version control just to get you in the flow. But before we do that, yeah, feel free to take a look at the books, and let's make a 5-10 minute break. And if you have questions, just please ask.
if you have something like this. I don't know if you are using a lot of slides here, but do you have them in some system?
Yeah, I'm gonna upload them. So I'm recording right now as well.
Oh yeah, like
it's gonna be on YouTube and yeah, I'm gonna try to upload them on my courses as well. Yeah, it's the course material. So no worries. But it has a very very friendly language. It actually reads like a book, you know, like a fiction book. So from the electronics books that I have read, this has the most friendly language. It doesn't have so much. Yeah, it as far as I have read, it's a very friendly language, so it kind of appreciates the fact that you might not be into formulas necessarily, even though electronics is not possible with all these symbols and graphs. But still, like the author is trying kind of to make it less abstract. This is still working. Yeah. Okay. And I'm going to go and make another coffee. All right. I think before we begin the Markdown session, I could just show you around the lab, so what is possible here. So here in this corner, we have a fridge, a broken coffee machine. So we are in process of getting a new coffee machine, but that's another story. Then we have a screen, so where there's usually videos being played back, but not in the moment. But okay, about the practical things. So here, the simplest tool to use is the vinyl cutter, and with the vinyl cutter you can make stickers and also all sorts of things for T-shirts. So for example, you could make something like this. So there's this T-shirt foil. So you would cut out the shape. So this is with 2 layers actually. And then you would use the heat press machine, so something like this. You can make it.
What kind of is this material for the texture?
It's vinyl.
Yeah.
So yeah, this is my cat, and yeah, my girlfriend made this for me for my birthday. So and then the other things you can do, you can make stickers. So more like the stickers that you see there on the windows. So you can do really detailed stuff, and then you can use transfer tape in order to transfer the vinyl sticker to the window or to any other surface. Yeah, and how it goes, you load the roll, then you use Illustrator in order to send paths to it, and it does the cutting. So I'm gonna show you how it actually works tomorrow. Then let's take a look at what's going on here. So here we have some CAD stations. So if you don't have your own computer, then you can come here and use it. Although nowadays I would expect that every student would have his or her laptop. And if you don't have software, yeah, if you have to use commercial software, then there are many options that you can download from Auto IT. So in our case, make sure that you have Fusion 360, you have KiCad, the latest version, and that you have Adobe Illustrator as well. So these are going to be the three main things that you are going to use this week. Of course, if you are more into some experimental or exotic CAD software, or you're more into coding, let's say, I would understand that you use something like OpenSCAD, which is a programming language for CAD, which is really nice. There's also Lib5, SolidWorks also works, Rhino, but yeah, I'm not a specialist in those. So if you want to learn Fusion 360, then that's the thing that I can show you. Yeah, so there are these CAD stations, and then there are some things that you can use for 3D scanning. So we have this one is really old and outdated that you see on the table, but we have yeah, that one. But then we have Kinect, and we have also let's see, EV1, or so a more professional one, which is like 15,000 3D scanning camera. But these are locked there. I could show you separately. Then let's take a look over here. So we have electronics corner. Yeah, so starting with a microscope, this is very useful when you want to make really tiny stuff. And we have a reflow oven. So when you, for example, you order PCBs from Shenzhen, and then you have the components, you would apply solder paste, and then you put components one by one. By using your hands or a pick and place machine. So this doesn't work yet, but it will at some point. And you can put it in, you can heat it up according to a heat curve, and it's gonna solder the components to the board all at once. And then we have yeah, all kinds of components, so basic things, also according to the Fab Academy inventory list. So resistors, MOSFETs, and transistors in order to kind of drive bigger loads. So for example, you could use a microcontroller like an Arduino, or microcontroller board, or let's say you could use a tiny chip alone in order to drive higher voltages. They usually run on 5 volts, but you could use transistors in order to drive 24 volts, or you could use relays in order to drive your lights at home, or I don't know, a power station. Then all kinds of LEDs to make light. So this is what we are going to do on Friday. We're going to try to design a simple board which would contain only a battery, resistor, and a simple light, just to see how it goes. And then a bit more complicated components. So capacitors, they are sometimes useful. So these are not really related to electronics so much, but again, LEDs. So some motor related stuff. So we have servo motors here, so which are able to turn in specific angles, and DC motors, vibration motors that you would have in your mobile phones usually. Stepper motors, so these you would use to build machines actually. Yeah, so jumper cables, speakers, all kinds of switches. Yeah. So and then we have capabilities in order to build boards like these. So if you want to design your own Arduino shield or Arduino from scratch, then this is all possible. So this is there are milling machines that let you mill from both sides in order, so you can create double-sided PCBs. So these traces over here, they have a hole in the board, and then you flip over and this wire continues, so you just need to connect it somehow, the top layer with the bottom layer. So this is copper, in between there's sort of paper. Yeah, and you can mill this with a smaller precision milling machine. So and if one of you makes something that is in this direction, I would be very happy. And then we have all the equipment for soldering and solder. And this is so this how do you call it? So you use it in you heat it up and you put it on a solder on a point where you have solder applied, and it provides you the way to remove the solder. So it's kind of a sponge or solder, but it's wick. Yeah, I forgot. I just forgot the name of it. Then you can use also these vacuum thingies. So if you heat up a place and the solder becomes liquid, then you can press the button and it just removes it. So like this is for bigger drops of solder if you accidentally do something wrong. Then this is a nice tool. It's kind of a power generator. What do I do? Yeah. Is it connected there or it's here? Oh, yeah. So you can generate a specific voltage over here. Let's say if you need 5 volts, you can tune it to 5 volts. If you need more, then you can tune it to, let's say, 12 volts, and it goes up to 28. Yeah, so 24 volts. And here you can measure how much current is being consumed. So you can see how much your circuit is eating electrons, basically. And instead of using battery, I think this is a good option. Yeah, because you can regulate the current very precisely. Then an oscilloscope. You'll probably not use this, but it might be very useful when you're doing something with digital signals. So you have two boards, they are intercommunicating, and you want to see the pulses. So you can see the pulses here, really with nanosecond precision. Yeah, and the other tools, haven't explored all of them yet. And some more components, some more solder. Yeah, there's also flux. So when soldering, it makes use to use flux, which makes it easier for the solder to snap the components. And here we have a broken 3D printer. So this is so if you read the 3D printing book, you will understand what is the stereolithography 3D printing technology, which is basically using a thin layer of liquid resin and a laser to solidify it, and then it lets another layer of liquid fluid in between, and then it solidifies the next layer, and this is how the 3D object becomes. But this is a bit broken, so there's something wrong with the mirrors, and there's something dirty we cannot really find out. We are now in the process of actually ordering a new machine, so hopefully we will get it. Like actually the new version of Form. This is Form 2, and like a month ago they released Form 3. Anyhow, so like a bigger version, but we are not gonna get the bigger version. We're gonna still go with a smaller one, but it's gonna be even more precise than this one. And then you usually, yeah, it prints, it sticks to the plate up there, and then you can take it out, you wash it for 10 minutes in one isopropanol bucket, and then you remove it, you put it into another, so it removes the excess resin. So isopropanol is removing the liquid resin. And then you put it in sunlight or UV light in order to let it cure. This is supposed to be a foam cutter, which would contain hot wire, and you would numerically control it. You would send a design file through a slicer, which would create paths for these to move, and then it would cut foam with a hot wire. Yeah, it would. I think it might be interesting for architecture students actually, because this would let you to build like big abstract structures from relatively large pieces of foam. But yeah, so we still have to find some time in order to make it actually make it usable. But yeah, for architecture students, it would be an interesting tool to play around. So basically, it could be also your project. So if you're into it, you can take over. There's documentation. You can actually finish building it. And yeah, if in a month it actually starts working, course is passed, you get all the credits, maximum points. Everybody's happy. So let's move on to the other room. So yeah, so this room is the busiest, like the fullest with machines, because it has ventilation, which still doesn't work really properly because of the way the building is built. So it functions, but it could function better. So this is the most used machine, laser cutter. So this is why I would like you to do something that doesn't use laser cutter or uses it a little bit. So I would like you to master some other machines. But it's a really great tool. So you can cut material, like plywood, plastics, also limited kinds of plastics. You need to always check what plastic you are cutting because the fumes might be really toxic. So plywood, MDF, acrylics, APAT, paper also, up to the thickness of 1 centimeter, but I would say 8 millimeters. And we have also a vacuum forming machine, so which is not really digital, but what you can do with it, you can use a thinner piece of plastic, you can heat it up so it becomes jumpy, like almost liquid or flexible. And you can have underneath, you would put a 3D model, like a positive mold, and then you would use vacuum in order to pull that molten plastic around it. So you would end up with having a negative shape. Maybe if you've seen where there's the foam cutter, let's go a step back. But no, wait, I'll just bring it here. So yeah, basically this was made with it. Yeah. But yeah, no. Oh man. Yeah. It's not really. All right. I thought it's cured. It's standing there for a month or so. Yeah, be careful. I'm sorry.
So the guy who left this thing printing,
Yeah,
he has a problem with 2 of his files. So they're not all in the same position on the Z-axis, of them are higher. That's like an accident. It's not supposed to be like that. Can I fix it from an STL file?
I think that he should come here and fix it himself. So yeah, a lot of people also think that Fab Lab is a place where you would arrive and you would treat it as a print shop, which is not. So it's kind of the idea is that we can show you how the tools work, and then it's up to you to master these tools and try to solve the problems, because this is the way how you learn. And this also empowers you to use the lab for your own projects in the best way possible. So yeah, so what you can see on the other side of the room, so here, so these are the 3D printers, so which is a bit different technology than the one we saw before, so the Formlabs. So this technology is called FDM, or it translates to fused deposition molding, which means that you are basically molding an object by melting or liquefying a specific material and then creating volumetric lines layer by layer and building up the object by.
What's the difference between this one and this one?
They're the same. Yeah, they're all FDM printers. So they are just different brands, and so some parts are different, but the way they function, so the idea behind them, it's the same. Just give me a second. Yeah, the good thing about them is so we encourage people to use PLA, which is a biodegradable sort of plastic, so relatively biodegradable. It's much more environment friendly than ABS, for example, and it's much more environment friendly and easy to work with. As for example, the resin of that one, because you saw it leaked, it was not so easy to clean it up. So if you wouldn't use isopropanol, then it would be like a really bad gunk and hard to handle. Yeah, and with these, but this method has limitations. So, for example, there's this concept of overhangs. So, for example, in this object here, you know, the chin. Yeah, you can use support, but like the problem is usually this overhang that you know, the printer, it cannot really start printing in plain air, so it always needs something underneath. And this is why the slicers, which is software which is used to convert 3D models into instructions for the 3D printers, why they have usually an option to generate supports for certain levels. So it usually measures like the angle in between two or more layers, and then based on that it figures out where the support should be. And usually they are made in a way that they are easy to remove. And I think there's already some architecture student using the machine. So these ones, they have the heated build platforms also, which means that these platforms are being heated up in order to improve adhesion. So the first layer usually heats better if it's heated up. But then, for example, this doesn't have a heated build platform, but instead of that, a tape is used. So an adhesive tape is used in order to make the first layer stick. So the first layer of plastic is kind of melting, and it's fusing with the tape a little bit, so that the tape holds it down. And this is a bit more. This is a really stable machine. So as you see, it has an aluminum frame. It doesn't move much. So the mechanical parts in it are really precise. So this is a very reliable printer. And by the way, made by a startup in this building, which is called Markdown Industries, and the price of it is around 3,500 euros. Yes, not the cheapest one, but yeah, kind of understand why, because it's nice and precise.
It seems that this goes wrong.
Yeah, there is something going wrong. But you need an interface in order to stop it. So that's hey, but there's so the prints are failing. Maybe you can stop. So there's like the filament is sticking to the nozzle. So probably you have the interface open. Maybe you can stop it.
Yeah, I think it's probably the same as the other one, like because it's not like set on the build plate.
Oh yeah, maybe there's some problems with leveling. Yeah, I wonder. So the slicing is wrong then.
Yeah, like I can have it here. I have it there, but I opened
yeah.
it up. And
Maybe
one of the pieces was on the build plate.
Yeah, let's look at it a little bit later. So probably there you would need to. So you would use isopropanol also to clean it up a bit more. Then we have these precision milling machines. So these machines are used to produce these PCBs that I showed earlier. So there are a lot of experiments that we are doing lately. So this is quite a relatively new machine. We got it a few months ago. It's actually it's a nice machine. So if you haven't used the CNC machine, then probably this is the best to start with. Not necessarily with cutting PCBs, but with cutting out something really simple from plywood, for example. Because yeah, it's easy to set up. It's a controlled environment. Not so much dust. The software is relatively easy to understand and it helps you understand the basic concepts of CNC milling. So if you don't have any experience, I would suggest you kind of to try this out. This is similar, but a bit more advanced machine. So although you would run the job for it in a similar fashion as you would run with that, it's in a way it's a bit easier to set up because of the automatic Z-axis. So this is a Roland Modella MDX40. And you can also insert the fourth axis, which looks like this, it looks like a lathe a little bit, which basically lets you rotate the material like this. So let's imagine that there's a spinning drill part, like milling bit part, which moves around an X, Y, and also Z axis like this. And then you have this fourth axis, which allows you to rotate the material. So basically, you can do 3D milling, so things like these, for example. Yeah, so for architecture models, it could be really beneficial. So you could mill one side like this, and it automatically turns it like that, goes over. So if somebody does something with this machine as the final project, you're okay. You're fine. So you can just come here every day for the next month, and if you just work with this machine and figure out how it works and how to do the 3D milling, you pass the course. That's some good knowledge to have. And then another thing. So for example, this is made with Fusion 360 and this machine, a bigger CNC machine. Which can be used for making furniture and also bigger three-dimensional objects. So let's say you want to have a mountain-like structure or a city model in the scale of 1 against 1,000, or I don't know, even smaller. Then you can do it with this. So it travels 40 centimeters along the Z-axis, and then 1 meter 20 along X, and 1 meter 30, basically 1 meter 20 along the Y-axis. But I usually try to limit it within 1 meter, because sometimes it becomes unpredictable. You don't know where it starts counting and where it stops, really. And then it has a nice feature, which is the vacuum bed. So you can open these vents and you can make it so that the material is being pulled against the table. So you don't need to use necessarily fixtures. So you can use some fixtures as well. So if it's a smaller material that you cannot really fixture by using the vacuum table. So you can use those, but if you are cutting something for furniture, so bigger pieces, then this vacuum bed is really nice. So this is also usually necessary to use the sacrificing layer. And the good thing with the vacuum table is that it can pull air through an MDF board, which this is. So it's relatively porous, and air is flowing through. So it's pulling the material down. And foam, no. So foam doesn't work. You have to attach like a piece of paper underneath in order for it to stick down. But like other materials, like pieces of wood or MDF or plywood, they are sticking to the build plate very well. But this is what we are going to look at on Thursday. Yeah, Fusion 360, tool paths, and CNC machine. Yeah. And then we have so when job is done here, so when you have your parts and your design, you can go here into our assembly room. And you can use this space in order to clean. So for example, in CNC machining, you usually have tabs or rough surfaces that have to be sanded or post-processed. Then you can find also some scrap material that you can use for experiments or new designs also to be milled with a CNC machine. So yeah, and you'll use this to assemble things together and finalize your design in a way. And it is equipped with all kinds of hand tools, knives, screwdrivers, saws, and so on. And then we have also some materials available on the spot, which you can find in the storage room. There's also a painting room if you want to use it. So storage room, so we have foam, like XPS foam that could be used for milling 3D surfaces. So you can consider that as an option. So if you want to make some 3D surface and you want to experiment with a CNC mill, so you would use that. Then we have acrylic sheets and plywood and MDF. And the policy is that let students to use the machines for free. The material has to be bought, but as you're joining the course, then you have a budget of €50 each in order, or it was 40 or 50 euro each in order to make your project. So you can choose your material, or maybe you should, if you find a similar material that is cheaper somewhere else, we could reimburse it as the expense of the. Yeah, so we should actually label those, but it's a good idea always to check with the caliper how thick they are. Yeah, and that's on top of that, it's really nice to have the lab not far away from the metalworking lab. So if in case you need some extra features, some extra fabrication tools, hand tools, or automatic tools, then we can ask the workshop nearby. So here, so this is stage design workshop. So the primary use is to build structures for stage and movies and theater. So here you can also usually find some scrap material. There are some bigger pieces, so interesting material that you can find there. Some good plywood sometimes. Cuts really big pieces of plywood in all kinds of angles with that tool. Can really precise angles for wooden beams with this tool. Then hello, and then in there we have also a metal working lab. So there, let's take a I'm sorry, the metal working part. So there's a lathe. It's a really cool thing to have. Okay. And then here it's everything needed for welding projects. Yeah, like really heavy metal working place. But yeah, in order to gain full access to these spaces, there's another course. So it's just in case you need something thing, and there are people whom you can ask, and they could actually figure out a way how to help. Yeah, so that, I think you can sand metal with that. Okay, good. So do you have any questions so far? More questions? Okay. Well, yeah. So let's not stretch things too much, and what I want to show you is a few things in terms of documentation. So what I would expect from you. So basic text editing. So basically, it makes sense to get text editor, such as Sublime, or there are other versions. So for Windows, there is Notepad++, for example. This is a really nice tool. So plain text means text without formatting. So also these colors, it's rather more like for highlighting some coding language styles and syntax. But it's just plain text without the ability to make it bold or underlined or anything. So it use specific symbols to do it in some more like higher level formats. But yeah, so you would Notepad++ is one option. Then I think on Mac there is Brackets, which is a nice editor. So it's a nice thing to use for web design. So so far I accidentally have used it in the computers over here, and it works really nice. Yeah, made with JavaScript. Then there's Atom, which is a completely free and open source editor that looks the same on all platforms, on Mac, Windows, and Linux, which is really nice. And then I'm kind of used to use Sublime. So it has nice, powerful features specifically for programming. So you can start typing at many places at the same time, and yeah, well, so you could use also Notepad or TextEdit, but I would recommend you to get one of these better text editors. So I'm going to show you the demonstration using Sublime, and day one. And in text, there are many ways how to make a title or subtitle and separate paragraphs of text or make tables and such. But luckily there's Markdown, which is a flavor, which is a simplified kind of markup language for doing these things in a simple text file and making it readable by humans and computers alike. So it's a similar idea as with the HTML, but actually it's much more readable. And actually the slides that I showed you previously, they are done in Markdown. So this is how it looks like. So you can have title, comments, separators, but this is like specific for the slide software that I'm using. Yeah, and in order to get this structure, we can use Markdown, and there are a lot of resources out there which have so-called cheat sheets or manuals for Markdown, and it basically looks like this. So all the elements that you would use for writing a book or article or your master thesis, you can find them here. So maybe not all of them, but you know, the most popular set of features. So so it's more like based on what is possible with HTML. So headers, so top level header or H1, like with one hash in front of it, second level #2 and so on. You can also underline them. This hash syntax is more has more logic to it. And then if you would use any Markdown to HTML parser, then you would arrive with this kind of HTML appearance. Then you can use all kinds of emphasizing features. So you can use like asterisks for italics, or like underscores for underscoring text. This could be for bold, for striking it out. So yeah, this would translate to these kind of things. You can also add lists. Lists are really simple, so you can, as you see, just go 1, 2, 3, and it would actually look like list. So let's see. So for example, like unordered. There's a difference between unordered and ordered list. Unordered is that the sequence doesn't matter. And then there's an ordered list, which is more like one. Looks like this. So it's readable in text file, and then it's being translated into HTML afterwards, like a real list. Then you can also insert links. So there's a syntax for links. So for example, so first you type the text, and then you can use the square brackets. So this is going to appear as the visible part of the link, and then when you click, then it's going to go to something like to the address that is specified in the normal brackets, like this. Then references, so you can skip those, but images are important. So for example, if you keep images in separate files, then so you start an image by typing an exclamation mark like this, and then you use square brackets to provide alternative text just in case the image is not possible to load. So in HTML, it's important to have this text because it's what you are going to see if your browser is not able to find the image. And then, so here you can specify a local path to the image that is actually in the same directory where your project is, where your documentation is. I'm just gonna make a directory on the desktop which is called Markdown demo, and I'm gonna call the file documentation MD. MD stands for Markdown, like so. And so yeah, to demonstrate this, you need a Markdown viewer. So there are viewers that you can install, but what I wanted to show you, so another bonus for you, so if you do your documentation in text format or Markdown, so I would be 100% happy if you would also learn to make a GitLab repository. So for example, this is my account. I could make a new project. I'll call it DFS documentation demo. Enter something for the description and create the project. Actually, I wanted it to be public. Where do I have the settings? Yeah, would it be public? Save changes. And yeah, and here, for example, I'll need a terminal. And what I'm going to do, I'm going to navigate to the directory where I just stored the file. So it's going to be Markdown demo, and here and I'm going to make a Git repository with Git in it, and Git status is going to tell me what's not added to the repository yet, and I'm going to add the documentation file to the staging area, and I'm going to make a commit. So commit means that I'm just registering a certain action in the versioning of my Git project. So for example, if I do some changes in a source file or in my documentation, like let's say I added a paragraph of text, and I can in this moment I can say that I added a paragraph of text. I hit enter, and then I can use git log. So there are also, it's not necessary for you to use the command line one, so there are also graphical user interfaces for this. But the benefit of why? Okay, because I had to add -m. So, but the benefit of it is that when you type git log, then you can see all the history. So now all the history is one commit, but let's do it like so that I will change this. I will add day 2. And I can go back here and type git status, and Git will recognize which files have been changed. So it's going to try to calculate the difference between the previous files in your version history and the actual files that are there, and yeah, in my case, it Git sees that documentation file has been changed, and I have to add it, or it's going to be like this, and then I have to add a message to it that what has been changed. And now, if I type git log, so I can see that the history, so with all the data. So when it was when the change was made, then my description of the change, and also these IDs, they mean something. So for example, if you copy them and then you type git show and the ID of the thing, then Git is going to show you what exactly has been changed. So here you can see like everything that is with plus is the added content. And so for example, let's check the last one. Yeah, so you see that this was added, and then let's try to remove something. So I will remove this lorem ipsum line and add a dot here. And again, Git sees that there's change. We'll add the change. Now git log. So we see that there are 3 entries already, like 3 history entries. And yeah, git log. So I can copy this and here you can see that there's like these red ones with minus. This is the text that has been removed. And you see, I just added a dot, but Git actually thinks in terms of lines. So whenever you change a line, it's just removing that line and adding a new line. So yeah, you see that so this content was removed, and then a new line with a dot at the end of it has been added. And this white text over here just shows you the context, like the broader context, because there could be many parts with the same content on your document, but then like the things around it, they're different. So you can see which part actually did you change in the history. Like so. And then once you make a Git repository in GitLab or GitHub, so that's also an option. So what you can do is add remote by using this line, but if you're starting from scratch, then all of these instructions are relevant. And with git remote add origin, I'm gonna just add my repository to the git remote system. So origin is kind of an alias for the actual uplink. So for the server location of my documentation, somewhere on GitLab or GitHub, and then the following is the address of it, like so. And then if you go here, so it demonstrates you also how to add a commit, and then for the first time you should just use this git push command, and it's gonna upload the documentation to here automatically. Now it's here. I can click on this, and it's going to automatically going to translate the text into HTML, so the Markdown text into HTML. And as you see, there is no image, so let's add that. In order to do that, let's browse some images online, or let's just actually look up something on my hard drive. So I'm going to go to Dropbox, camera uploads, dirty dishes, no. So this, for example. So where was it? Markdown demo, and I'm going to paste it here, and I'm going to rename it to lead shield. Like so, I'm gonna copy this name, go to the Markdown file, and here where I'm adding the image, I'm gonna change the text to LED shield, so in case it cannot find the image, and just enter the name of the file, like the full file name or the full path to it relative to the place where the file, where the MD file is, and save it. Then go back to the terminal, type git status, so it sees that the documentation file has been changed and that there's a file that hasn't been added to our history. I'm gonna add the lead shield, and I'm gonna add git documentation, and I'm gonna git commit -m, so with a message that added valid image file, git log, just to check whether you have, so the history is there. This looks nice, and this time I just need to execute git push, and it's gonna push to my repository. And now I'm going to refresh. And here you are. There's the image. And then when you go to the root of the documentation, so you see only the files that are there, but there is an interesting trick for GitLab and GitHub, that when you rename the documentation file into, can I rename it? Here, no. Yeah, I'm just gonna close this for now. New rename. So in command line, you would use a move in order to rename files, and if you rename it to readme.md, then it's going to display the readme file automatically, so together with the files. That's going to be the first file which is going to be visible in your Git repository. And if you are renaming, then you need to kind of add both the old version and the new version of the file, because this is how Git records a change, like a rename change. And I'm going to push it to the, so yeah, and now you see it's automatically, you see the files and you see also the documentation. And yeah, it goes even further than that. So on Git and GitLab, you could actually take this Markdown and you could convert it into your website as well. So you could go and create GitLab CI YAML file, which is going to use the continuous integration capabilities of it. And you can just take one of these like HTML, for example. Is there something that would transform it? Wait, let's do a quick search. Yeah, I need to look into this a little bit, but so yeah, let's start with HTML. So if you go to the root of the directory now, so what it does, so what this file does, it gives instructions to the continuous integration engine in order to make a new directory that is .public. Then copy all the contents from our repository into this directory, and then move this directory into public directory. Yeah, and then this artifacts part specifies that GitLab should store the public directory and delete everything else. And this public directory is going to be published as a website. And in order for that fully to work, I think we need to enable the pages option over here. And this would be the actual web page. And it has nothing on it yet, but if we try to access the readme MD file, it should give us that. Come on. Okay, I'll pull down the latest changes from the repository now. And I am going to create index HTML file. So sorry, this gets a bit complicated, but so I'm going to add an index file, which is usually the first page that is served from a web server to your browser. So now it's building. Could be that it has like this. No. So theoretically, it should show up here. Yeah. But the basic idea, so this is a bit more like an overkill. What I would like you to have is, so as a maximum thing is just a repository where you have your Markdown file with images like this, and maybe separate files for each of the days. You know, this would be just enough. And then for the video, yeah, that would be also as a separate file, and everything would be nicely visible, and I could also see, so what is the history of the things that you have done. You don't necessarily need to use Git all the way, but you know, just as an exercise for your future projects, it would be useful if you try to kind of tap into it. In order to learn Git, you can go to git.scm.org. So you can get all kinds of versions. So there are graphical user interfaces and command line tools. So I have been using it from the early days. So this is why I stick to command line, and for me it's much more easier than a graphical user interface. But yeah, feel free to explore this tool. So it's really good for anything that is text-based. So you can even version your design files with it. So in Fusion 360 it works differently, but then if you use something like FreeCAD or Blender, then you can use Git in order to version it. So you never, so for example, if you do a last-minute change and actually the previous version did work, then if you're using Git, you can roll back to the previous version and it still works. So that's the idea behind it. And then it could be also a great collaboration tool. So if there are many people in team using Git, then you can each of you can clone the same version, and you can work on 3 files separately, and then you can merge all the changes together in a single project at the end of the day. But yeah, so yeah, documentation format. And did I have anything else for the slides? So yeah, so there are some resources for you to explore. So the Markdown cheat sheet in order for you to understand a bit more about Markdown if you want to practice that. And then about Git, so Git SCM site that I just showed, then GitLab is the place where you can make your own repository, and GitHub, it's similar to GitLab, but with a different philosophy and tool set. And yeah, and that's it for today. So thanks for joining, and then see you tomorrow. And tomorrow we are going to dive into Illustrator and vinyl cutting and laser cutting. And please read some things, like some of these things, or find an article online so you could yeah, it would be nice if you could tell something, if you could have a short but a short beginning discussion about what you have learned about digital fabrication in Fab Labs. Thank you. You're free now.